Hi guys, this is a calc video to be watched Thursday, um, January 9th. And the homework that corresponds to this is going to be page 7 in the homework packet, numbers 1 and 4. So we're going to do examples that are very similar. And this is a new topic. I hadn't had to do this last year or the year before because it wasn't in the curriculum. But I learned that this summer that this is going to be in the curriculum. It's almost like how you had to use the limit definition to identify a derivative. This is using a limit definition to identify a definite integral. And remember that a definite integral is just the exact area under a curve. Okay, so these two definitions you need to know by heart, okay? And I'm going to show you how to use them. So choosing the right endpoint of each subinterval, if you want to find the exact area, so the definite integral, the integral from a to b of f of x dx, I'll say dx, this is the exact area under the curve f of x. And the way that you do this is that you take a summation of the areas of a bunch of different, of a bunch of rectangles that are underneath the, between the curve and the x-axis. And f of this is what gives you the height. Remember, the function value gives you the height. And then you multiply it by delta x, which is the base of each rectangle. And so we're using n rectangles here. Okay, but if you take the limit as n goes to infinity, then you're actually using infinitely many rectangles. And, you can't even see that with a naked eye. So it's basically just, going to look like the exact area under the curve. Okay, so an observation to make is that delta x is always b minus a over n. B minus a is the length of the interval that you're on, and then you're dividing by n, where n is the number of rectangles that you're using. And I'm really kind of going fast here, guys. I don't feel like I developed this definition very well. It is a pre-calculus topic, so maybe I could find some videos that people have already made to help you, understand this notation better. Okay, so the notation, the summation notation, that was a pre-calc topic. Okay, so choosing the left endpoint of each subinterval, it looks almost the same, except you do k minus 1 here instead of k. Alrighty, so express the definite integrals below as limits of right-hand and left-hand Riemann sums. Alright, so I'm just going to take this, and you're just going to use this like a formula. I know it's very complicated looking, but you're just going to use this like you would any other formula. All right, so the first thing I want to do is I want to identify A and B. Okay, so that's A, that's B. F of x is that function right there. And I also want to identify delta x. Okay, so delta x in this case is going to be b minus a, so 12 minus 4 over n. Okay, so this is 8 over n. That's what delta x is. All right, then I'm just going to plug stuff into the formula. Okay, so the right-hand sum, I'm using this formula. So I'm going to have the limit as n approaches infinity, summation, k equals 1 up to n. And then we're going to do f of a plus k delta x, okay? So my function f is this here. So I think this is a good idea. If we, let me go like this. I'll write it, I'll write it like this. I'll go 2, leave a blank for the input, plus 6. Okay, and then we'll fill in the blank later. All right, so this here, maybe this will help. So this part here is corresponding to that part of the definition, all right? and then times delta x. So on the outside, delta x we already figured out was 8 over n. Okay, now what has to go inside of here? The input of the function is going to be a. So what is a? In this case, it's 4. So 4 plus k times delta x. And guys, k is a different number for each term of this sum. Okay, so we're going to leave k as, as k here because it's going to change for each term of the sum. So it's just going to be 8k over n. 8k over n. And I know this is probably confusing, but you really will get used to it. All right, so there it is as the limit of the right-hand sum. Okay, now limit of, we're going to express the same exact definite integral, but as a limit of a left-hand sum. We need to be able to identify both of these. So I'm going to do it very much the same. I'm just using this formula right here. So I'm going to have the limit as n approaches infinity, so the number of rectangles under the curve is approaching infinity, which will end up giving us the exact area. And then summation, k equals 1 up to n. Okay, so I'm going to do this just like before. The only thing that's good, that's the only difference between these two definitions of a definite integral is that instead of k, you have k minus 1. Okay, because this is for the right endpoint. The left endpoint would be, to the left 1, so k minus 1. And then, so we're doing the same exact function, 2, and I'll leave a blank for my input. Okay, so that's f of x, but f of blank instead. And then times delta x, which we figured out was 8 over n. Now the input this time, all right, so I'll color code again. So this corresponds to this part of the limit definition of a definite integral. So what goes in here? Again, just like before, a, so our a was 4, plus, instead of 8k over n, we got to do k minus 1 times delta x. Delta x we already know is 8 over m. So 8 over n times k minus 1. So we'll have 8 times k minus 1 over n. Okay, so there's that. Let's do it again. All right, you will get used to it. So this here, just like before, so I would write an a and a b there, and then I would figure out, delta x is equal to, this time, b minus a over m. So 6 minus negative 1 is 7 over n. And then we're just going to use the formulas. So the limit as n approaches infinity, okay, summation, k equals 1 all up to n. That part is always the same. Okay, so that part is always the same. Now I'm going to take my function, which is a sine of 2x, and I'm going to leave a blank for the input. So we're going to have sine of 2 blank times delta x, which is 7 over n. And then what's going to go in the input of the function? We want to do a plus k delta x. A is negative 1 plus k times delta x, so k times this, so 7k over n. 7k over n. All right, so there's that. These two things mean the same exact thing. All right, you only are going to have to use this, guys, for identifying like what definite integral you're working with. Okay, so what we'll mostly do is like the next example when we're working with these. Okay, and now one more. So it starts off the same. The limit as n approaches infinity, summation, k equals 1 up to n. I'm going to take my function, and I'll leave a blank for the input. All right, I'll leave a long blank because the left-hand one, you need a k minus 1 instead of a k. So times 7 over n. And then inside goes a plus k minus 1 times delta x. So again, just like before, k is negative 1 plus this is delta x. So you could always, it would be helpful to always look here. That's delta x. Right here, we've just got to multiply delta x by k minus 1. So 7k minus 1 over n. Alrighty, so there's that. Now, mostly, I think I'm going to ask you to do these things sometimes, like, you know, translating from a definite integral to a, you know, left hand or right hand Riemann sum. But normally, guys, I think these are going to show up as multiple choice things, okay, which is the good news. So, so this is more like what we're going to be working with. The limit below is equivalent to which definite integral? Okay, so clues to look for. All right, I would say that the first clue to look for would be the delta x, I guess. All right, so I'm gonna look at all of these separately. All right, for this one, delta x would be 4 minus 0 over n, so it'd be 4 over n. For this one, delta x would be 5 over n. And for this one, we would have delta x being also 5 over n. And it looks to me right here, I mean, really you could commute that 4 and the 5, but I don't think they'll try to trick you like that. If you commuted the 4 over 5, maybe you could say, oh, well, maybe delta x is 4 over n. But I would just say that this, pretty clear that that should be our delta x. All right, so that eliminates a, okay? And now we just have to match it to the function, okay? So let's just say for the sake of argument, I think that this is the one, all right? Well, guys, if this were the one, if this were it, then, you know, then I would be plugging, then for example, let's pretend maybe I think it's the right-hand one. Well, then I would have the limit as n approaches infinity, k equals 1 up to n, for, leave a nice blank, times 5 over n. So a is 0 plus k times delta x. That's delta x. So k times delta x, 5k over n. And this is not going to simplify to be that. We just have a 4. There's like no input there. It looks to me like that should just be a constant function. So the answer, in fact, is B. Okay, guys. So yeah, we'll practice more of this. You will get comfortable with it over time, I promise. Okay, so there's that, if you're working hard anyway. So the homework is page 7, numbers 1 and 4. All right, I will see you tomorrow. Bye-bye.